looks like we're live. Hello everyone and welcome to yet another Zuzin session. How about that? How about that? Bet you didn't expect that shit to happen. So let's make a little bit of an announcement and maybe officially start the stream. So let me grab my Discord server, and let's make an announcement. Red Circle live on Twitch. And what are we doing today on twitch.television? Today we're hacking a C compiler. That's right. So that's a very interesting topic for today's stream. So it's more of like a one-off topic. I don't plan to actually stay on it for too long. It's just something that I wanted to try for quite some time. Right, so the announcement has been officially made, and hello everyone, welcome. So the topic of today's stream is basically summarized in a single tweet that I've made some time ago. Right, so the tweet is basically this. So I'm gonna copy paste this tweet to chat, and also I'm gonna put it into the references because it's a part of the references. So it's about the C programming language. If we allow dot being treated automatically as arrow in C when used on pointers to struct, how much existing C code would be broken? This is actually a very interesting question. So what it's all about, right? So what is dot? What is arrow? I'm gonna presume that majority of people here know C, so you know that you use dot to access the fields of the structure, and arrow to access the fields of the structure when you have a pointer. So it has like sort of like an auto-dereferencing. Maybe I should explain it. Maybe I should actually start from the beginning. Lazy0008, thank you so much for 6 months of Twitch Prime subscription. Thank you. Okay, so let me go somewhere, maybe here, and let's do something like C auto-dereferencing. That's actually called auto-deref, right? So I'm gonna do something like this. Right, and let's go. Let me also make sure that this entire thing even compiles, right? Because if it doesn't compile, it does not work. So essentially when you have a structure, right, so for example let's say foo, and we're gonna have a couple of fields in here, A and B. So, and you define a variable with the type of structure, right, and then you do something with that specific structure. You maybe assign some fields, right, so it's gonna be foo B. Let's put it this way, let's actually say it's 34 and this is 35, and we want to do something like printf d foo A plus foo B. Not really equal, I mean plus. There we go. So we have something like this. This will work and it will print 69 as usual, right? So as you can see, it is 69. And here we use dot as a way to access the fields of the structure. Quite often I have the following refactoring strategy, right? I have some code that works with some variable. And then I want to move that code to a separate procedure that accepts that variable by a reference or by a pointer, right? So, and let's actually do that. So let's create a field, not field, function called bar, and it will accept a foo, but it will accept it by a pointer, right? Something like this. And what I do, I just copy paste the entire chunk of code. I just factor it out into this procedure, and I just do bar foo. And this thing does not really compile anymore because what? It wants an arrow. And furthermore, the modern compilers are actually so smart, they even tell you, did you mean an arrow? Right, so, and that forces you to just go and replace all of the dots with the arrow. In this particular case, it is actually nothing. It is actually pretty straightforward, right? But the code can be bigger. Okay, but for a bigger code, you can just use search and replace, that is fair. But imagine that you're programming in C for like 30 years. I'm not programming in C for 30 years, but imagine that you're programming in it for a very long time. And every time you do this refactoring strategy, which is actually pretty common, it's a pretty common refactoring strategy where you take a piece of code and extract it to a separate function. And every time you had to replace that dot with arrow, back and forth, because sometimes you want to do actually the opposite thing. You want to just, change it back to where it's by value. And it's so annoying, and a lot of people who develop languages actually realize that, and they allow you to basically use dot for both of the cases, right? When you want to dereference the pointer, or you just want to access the field by a value, right? Languages like Go or Rust, they just allow you to do that, right? So, but we can't just do that in C because, backward compatibility. We have to preserve the backward compatibility because there's so much code written in C. We cannot afford adding these sort of fancy features, but this is the trick. Is it even backward compatible? Think about it. If we just allow the dot being treated as arrow, how much code will it break? We don't remove arrow from the language, we just allow the arrow exist. We just treat dot as an arrow every time we apply it to a pointer to a structure. The existing code that uses arrow still works. The existing code that uses dot still works. It's the new code that will use that feature. So theoretically, if we just allow that, none of the existing code would break. Though the new code written for that specific feature may not work for all the compilers, but yet you have old code and you will still be able to use that. Only C++, who cares about C++? Come on, seriously? It's a dynamic. Look. TOB index. C++ is dying. Like, who uses that? C was always higher in ranking than C++. We'll just have to wait until KGB approves my query, but yeah. So where is C++? It's even less popular than Java. It's like it's going down. Though it's kind of growing in popularity, but anyway, so C is still better. So, and I do not propose to just introduce that feature, right? I'm just saying that it feels like not really that much code would break. And I was thinking, can we just implement that? Can we just take an existing C compiler? I think we're gonna go with TCC, right? So because it's the easiest compiler to comprehend. It's a very simple implementation of C. It is very small. And I already did experiments with C using that specific code base, just because it's so simple. Right, so I was thinking, can we just take TCC and just add that feature and see how it works? And maybe recompile TCC with that feature and see if the compiler still can compile itself. That's actually a very interesting question. What do you guys think? So I just wanted to try that, right? So I'm not proposing to change the standard or anything. Let's just try. All right. So, okay, good. So that's basically the idea for today's stream, right? So let's go ahead and do that. So I probably want to download the latest version of TCC, right? So is it even developed, right? So because I'm not sure, I think it's not developed anymore, or it's like, maintained by some community, but not the original author. But anyway, so let's actually download that. What I remember about this implementation is that it's super quick to compile and it's really easy to navigate. That's the only thing I remember about this thing. Look how simple it is. All right, so do we have configure? We do have configure, and can I do something like configure help? All right, so let me see. So we can set the prefix, that's fine. We also can set different like CPU things. Let me actually quickly open my window because it's a little bit harder here. Okay. That's what my parents always told me in the clothes shop. We are not gonna buy it, just try it. Yes. That's exactly what we're gonna do. Alright, so let me see. We're gonna do configure. And okay, so it just configured it. I'm thinking, should we install it somewhere? Should I set the prefix to install it somewhere? Because maybe it needs some sort of an environment. Maybe it doesn't really matter. So let's just try to build it and see if it will require anything. We're compiling it with GCC, by the way. Right. So we're bootstrapping the compiler with itself. Alright, so we have warnings. Nice. That's very cool. Thank you very much. What a nice implementation that has warnings. And that's literally it. That's the entire compilation process, which is quite surprising. So where is the executable? Do we even have the executable? Let's find files which are executable and has the name GCC. Do we have such files? Yeah, there we go. So this is literally such file. It does exist there. And if we take a look at the type of that file, right, it is elf64 lsb py executable and dynamically linked. We can also take at it dependencies, right? So it's GCC. And it doesn't really depend on too many things. So it's going too fast, I'm afraid. I'm afraid the implementation going too fast and I won't have any like content for like 2 hours, right? So maybe I'm gonna fill it with something else. We'll see. All right, so here is an example, right? If I try to compile that specific example with TCC, what kind of error will we get, right? So I'm pretty sure we're gonna get something like include file stddev not found. Nice. All right, maybe it doesn't really matter. You know what I mean? So how about we do not depend on printf, right? So if I just don't do that, struct or union expected. Oh, I see. Okay, I see what's going on. You see, it encountered dot, right? And on the left side of the dot, it expects structure or a union, right? Which makes a lot of sense. But this thing is not a structure, neither it is a union, right? So if I replace this thing with that, it will tell me that. Okay, so what's interesting is that what it will say if this thing is not a pointer, but it is using the arrow, right? So I'm actually quite curious. Pointer expected. Okay, that makes a lot of sense. All right. So let's actually go back to here. And the reason why I want to see the error message is because now I can take that error message and grab it within the source code of the compiler and find the place where it's happening. And the place where it's happening is probably the place that we have to change, right? You know what I mean? So that's basically the trick, right? So grep, let's actually grep it and see. So when we can't find that, what the fuck? Oh, I think I know why. Because this message is probably constructed. It is probably constructed, right? So essentially, you probably have some sort of a function that has sort of like a message, right? So as expected, right? And then you have printf type to string, where you have something like type struct or type union, right? And this thing sort of like works for any sort of types. Right, and that thing is stored somewhere in some sort of a variable, right? In some sort of a variable somewhere and something like that. That's plain. All right, so maybe we have to grep for something like expected and see what do we have in here. So relocate no more expected, file name expected, type should contain... Okay, this one is rather interesting. Oh, okay. So we only found something like this. Okay. Which is kind of close. Right. So, by the way, haven't tried to do any of that before the stream. Right. So I basically just remembered that tweet and I jumped into the code base. So yeah. So I'm just showing you my entire process of exploring someone else's code. Onions. Okay, so let's actually find where we use that specific function, right? So how can we find something like that? So let's see, it's probably, we can just search for calls, right? Which is actually rather interesting. Do we have things like struct or... Oh, there we go, we found it. So, okay, I overcomplicated the idea, so I thought maybe it's like automatically generated, or maybe you have some sort of like a bit mask for different types and stuff like that, and it generates the message out of that. Everything is actually way simpler. All right, so this is the function. So expected pointer on structure. All right. So, and let's take a look at this function, right? So we're inside of some sort of a function. Inside of some sort of, and that's a huge freaking function. Look at that. So unary, an unary operator. Unary. How do you pronounce that? I don't know. But yeah, it's a very interesting function. It's just like unary. Okay, so maybe that's not the only place where we have struct or union, right? So is that the only place? Yeah, it is literally the only place. Would you look at that? Struct, union, or your mom, right? So let's actually make a change in this error message and confirm that that's the place that we need to change, right? That's exactly the place that we are talking about. Okay, so let me recompile everything. Let's see how it goes. Unary. Okay, thank you so much. So it's pronounced like unary. All right, so let's go back and let me now try to compile this into a thing. Yeah, struct union or your mom expected. There we go. So that's precisely what we have in here. So let's actually go back. TCC gen, and this is actually generator. Expect pointer on structure. So vtop type t, vb type not equal struct. So, and it only checks for struct, but it doesn't check for union, right? So it doesn't check for a union. Doesn't check for a union. So then we do next. This is a very interesting compiler because it feels like it generates in place. It generates in place. Oh, okay. So thank you so much. Now, what I want to do, what I'm thinking, I'm just a little bit confused why it says expect pointer on structure, because that's exactly what we want to do in here, right? So that's exactly what we want to do. So here we have a field. So field not found. So what is next? It gives me... So let's actually see. So next, what exactly next is doing? It's probably void next, right? Maybe I should actually use C types or something like that. C tags. So, and I'm gonna take all of the C files and all of the H files. Right, so that should create tags. Did it create the tags? I think it should have created the tags, but okay. Now I'm going to try to do the following thing, where I just do tags and is not a valid tag file. C tags. I forgot how to use this entire thing. Right, so C tags. So, example. C tags with, okay, so it's -r, and you just like do that. But for some reason it's supposed to generate like a tags file, right? C tags -r, right? And I think I'm doing something wrong, because I remember it's supposed to generate like capitalized tags file, or maybe I'm misremembering something. I'm really not sure what exactly I'm misremembering. And I can't find such file. Right, so I hate modern internet. What the hell is wrong with all of this stuff? Okay. So C tags. So maybe it's something about E tags. Oh yeah, E tags is an Emacs thing. Right, so let's actually do something like that. There we go. E tags generated it. C tags for some reason didn't do that. Okay, that's what I wanted. It's really weird. I don't understand. Okay, finally, I have tags, and now I can go to different places. Here is the function. This is what I wanted. Okay, so C tags like didn't work for me. Okay. So return next token with macro substitution. Ooh, that's actually very cool. Oh, so it's sort of like streaming the macro substitution. It's not like, oh, that's so cool. Right, so it takes the next token, and if that token is a macro, it first substitutes it, right, and then only then gives you the next token. That's actually very interesting. Okay, so next is just simply next token. And I suppose the current token is located in this global variable of some sort, right? So all the state is, you know, handled globally, I presume. Right, so that makes sense. So we have a structure, then we're looking at C double, right? So we expect... So the token dot C double. I'm not sure what the hell is a double constant. Double constant. Float constant. That's that's a very interesting thing. Okay. Maybe it has something to do with, yeah. Because the double constant contains dot. It has something to do with that. Okay. So if the token is cint or int, we expect the field name. And then we're searching for the field name, right, in the vtop type. So, and I suppose that's what we're interested in, right? So vtop. I'm not sure what is a vtop. So, but it has a type. It has a type. So that's rather interesting. So what I'm thinking is that we need to go to the place where we expect the pointer, right? And just see what we're doing there. Just see what we're doing there and move that code in here. I think that's what we need to do. Okay, backseaters are back, so maybe I should actually, I don't know, do something, maybe, yeah, subscriber smart. Let's put subscriber smart, because people can't contain themselves. All right, so let me see. So I need to remember how to make the bookmarks, right? So because I don't want to lose this specific place, right? So bookmarks, list bookmarks, maybe put bookmarks. I don't remember how to use bookmarks, but maybe it doesn't really matter. Right. So what's interesting about bookmarks in Emacs is that because I kind of rarely use them, but like I use them for like a while, and then I don't use them, and I forget how to use them at all, right? And this is one of the features that I have to relearn over and over again, right? So it's just like so weird, kind of. So okay, I just want to set the bookmark, right? So I'm setting the bookmark in here, and if I want to do something like there we go. So here's the bookmark, and I also have this thing, right? So already have some existing bookmarks. All right, that's fine. Now let me try to do grep expect pointer. Right, let's actually find the place, and we expect the pointer in a couple of places, right? So in direction with full error checking in and bound check. Okay. So the vtop type b type not equal pointer and it equal to function return expected. So I don't think it's that thing that we need in here. So then in here vtop type b type. I still don't really know what is a vtop. You know what I mean? Right, so I'm still not sure what is a vtop. It's a s value. Right. It's some sort of a s value, and let's actually find s value super quick. So let me maybe find the definition of this thing. So it's located somewhere here. So value on the stack. On which stack? So this is a value type. It feels like a very really simplified, right? It feels really simplified. So to be fair, I need to make a small break. I'm sorry. So let's make a small break. All right. So I've got my tea. So let's actually try to continue exploring this entire thing. So let's find where the pointer is used, right? So interaction with full error checking and boundary check. So I didn't think that's the one. This one is probably just dereferencing, just a regular dereferencing. The second one here is a little bit more interesting. So we have a token go to. Right, which is rather weird, but yeah, it is what it is. Probably, maybe I want to actually take a look at different kind of tokens, because I'm pretty sure that arrow is a kind of token, right? So let's try to find where tok go to is defined, right? So let's actually try to find that. So this is the definition of go to. So these are different tokens. Cool. Maybe we can find something like that. That's a really interesting way of defining tokens. We can't find an arrow. Okay. So, it just simply does not exist. It could be that, okay, plus and minus are not like separate tokens or anything. That is, oh, okay. So it's a tiny assembler, but it's an, okay. I don't really know what's up with that, but sure. Oh, some of the tokens are like this. So they're checking them exactly. So maybe there is something like, but minus and greater are, wait a second. So does that mean, excuse me, that, okay, tcc main.c, right? Structure your mom, right? So I can do something like this, right? So that should compile theoretically. Emacs. Implicit declaration of printf, but anyway, it compiled anyway. Does that mean that I can put a space in here and it will work? Okay, identify, okay, so it cannot work. So I thought maybe they're tokenized as separate things. All right, which is rather interesting, but okay. So maybe I can do something like grep and just search for that specific thing. There's a lot of such stuff. So grep rn expect enter. So it's this one. But it doesn't feel. You know what? So we are at TCC gen, right? We are at TCC gen, and the thing is, it could be just desugared at parsing time or something like that. You know what I mean? Right. So since this is a generation, right? This is a generation. The desugaring of arrow into dereferencing plus dot could have happened earlier. That's actually a good point. It could have actually happened earlier, but at which point? And it's kind of interesting that here, like a generation and sort of like parsing are sort of smashed together. I'm not particularly sure what's that all about. Okay, so I'm gonna make a weird assumption that maybe I can find something like this. libtcc, so it has nothing to do with that. Has nothing to do with that. Where do we have tokens, right? So this is a TCC tokens. I'm surprised that we don't have arrows here anywhere. One of the things maybe I can do token equal, and let's see what kind of tokens we can find. Right, so we are just comparing the tokens. So we never kind of encounter arrow, right? There is such thing as token arrow, and I never actually noticed that. Okay, and it's not defined in here. Where is it defined then? That's a very good question. Tok arrow, right? So okay, this is a tok arrow. So this is that. Oh, it's a weird generated thing. TCC gen. Okay, so this is a tok arrow. Okay, it's actually very close to what I wanted, but oh, and this is a different place. Wait a second. This is a completely different place, because if I do grep your mom, okay, did I remove that already? Okay, I feel like I already removed that, so I think I'm going crazy. Okay, anyway, so here we have just an arrow, right? And if it's an error, we do... Okay, I see now. I see how it's going. Okay, so if it's an error, first we do an... So this is where we desugar that. So indirection is the desugaring. Okay, so everything falls into place. Right, so everything falls into place. So that's actually pretty cool. So that's what we have to do. It's rather interesting. So, I wonder if we can do the following thing. Right, so if it's an arrow, we do one thing. So we do that in direction. But if it's not an arrow, if it's not an arrow, we should probably check whether VTop is a pointer, right? We should check whether VTop is a pointer. I'm really sorry that it took me so long to actually figure that out, but I think I understand now. Right, I know that for backseaters is actually obvious, right? So, but here I also have to, you know, explore the code, also talk constantly and check whether the stream is working or not. So it actually takes away like a couple of dozens of IQ points. So I'm really sorry that. And also, for example, my keyboard has died, so, and I have to deal with this kind of shit, unfortunately, so it's kind of difficult. So I'm sorry that it takes me some time to figure out such obvious and basic things. All right. So let me try to do the following thing. So indirection, right? So where was that? So we check for the pointer, and if this is the pointer, right? So VTop type equal to the V pointer. I want to do assert and say we should probably implement something here, right? So essentially, this is not an arrow, right? This is not an arrow. It's a dot or C double. I'm not sure what is a C double, right? So C double is probably it's a floating point constant, right? So it's a floating point constant. All right. So, and let me try to recompile this entire thing. So I'm gonna just do USB. Oh, that will require to recompile like everything. Okay, so it doesn't like the lack of assert, right? So let's actually just include assert. Assert.h. Okay. Directive output may be truncated, writing up to blah blah blah. Okay, that's fine. Okay, so let's go tcc main.c. There we go. So it compiled, right? Nothing special has happened here. Now, if I do this thing, what it will do? Pointer expected. There you go. But that's not precisely what I wanted. What I wanted instead actually is to have a pointer and use a dot in here. Right, so just use a dot in here. Yep, there we go. As you can see, we should probably implement something here. Right, so essentially I have a dot, and on the left side I have a pointer. I have a pointer to a structure. Right, so, and this is precisely the condition that we actually caught. Okay. So what if I had something else in here? What if I had 5 in here, right? So invalid number, so it looks like a number. L value expected. Okay, so it kind of makes sense, sure. Doing something like this will work. Something like this will trigger that. I think we are on the right track. I'm pretty sure we are on the right track. So let's go to tcc gen, and this is going to be to do. And what do we have to do in here, right? What do we have to do? If it's a pointer, we just have to add the dereferencing, I think, like auto dereferencing. So we know for a fact that this is not an arrow. It's either dot or C double. Maybe we have to explicitly check for that. Right, if talk is this thing. So we're explicitly checking for that. Only then we're going to add some sort of a dereferencing. And how we're going to add that dereferencing? It's a very interesting question. In direction. So here, pointer type. So if equal function return, this one is rather interesting, but I'm not sure how to work with all of that. L value something something. So pointer type. I have a strange feeling that maybe I wanna, you know what? I probably should call this entire function there. Right. And my keyboard has died again. God damn it. Just a second. I'm not sure what exactly that function is doing there. You know what I mean? So what the hell is wrong with my keyboard? Okay, thank you, finally. Okay, or let's actually leave it as it is, just for now. And then we'll see how we can compress all of that. We can see how we can compress all of that. All right, so let's just rebuild everything. So let's do make minus b. I'm not sure if I need to do make minus b. Like, it rebuilds everything just in case. Maybe it's a waste of time. All right, so now if I try to do tcc main c, it compiled, but we don't really know if it works or not because it doesn't really link properly with anything, and I'm not even sure how to properly do that. So maybe I have to install it somewhere. What kind of computer are you using? I'm using the von Neumann one. I think this is the entire feature. It must be the entire feature, actually. So, but I need a working compiler that can compile things, you know. So let me see. So okay, so we already have TCC in here that is installed. Okay, so that probably means that I have to install it somehow. All right, so let me go. So I'm gonna do configure, prefix, home, opt tcc. There we go. So in terms of prefix, it's going to be installed there. Let's recompile it one more time, maybe with all of the cores simultaneously. And then we're going to install it there. All right, make install. Cool. So it's installed there. Hopefully that will work now. So opt tcc bin tcc main.c, and I think if I try to include stdio now, it should work. Okay, so it worked, and now I have a out, and that worked as well. So now, believe it or not, this is the same thing. Right, so I can try to compile that stuff. Right, so there we go, so it works. We have auto-dereferencing, right? So we literally have auto-dereferencing. Now, if you use dot on a pointer, it will just work, and it was actually easier than I expected. So yeah. Isn't that cool? So the next step I want you to actually try. So the question in the original tweet was, how much code will it break, right? So I think to confirm that this is a safe feature, whatever word safe means in this case, we need to try to recompile the compiler with itself. You know what I mean? Yeah, we should try to do that. But the question is, how can I do that? Maybe I have to do something in the configuration, right? So what do we have? So it's using GCC to compile itself, right? It's using GCC. Use C compiler, CC. It is GCC by default. So maybe this is what I have to do, right? So let me try to do configure, and I'm gonna say CC, and it's gonna be literally home. Maybe it has to be something like this: home, OPT, TCC, bin, TCC. Like use this compiler when you compiling this entire thing. Okay, so it's using different prefix, but I don't plan to install it anywhere. Maybe I have to do something like prefix. So let's do home, OPT, TCC, stage 2, right? So it's basically the second stage, like after the feature has been added. So the C compiler, that's the C compiler we're gonna use, and let's try to build this entire thing. And the compiler just rebuilt itself. I'm not even joking, the compiler, the one that has that feature, just rebuilt itself. But the question is, does it really work? So we have to install it somewhere. Let's install it. Okay, so this is a stage 2, right? And then if I go to OPT, TCC, actually, is it TCC? Stage 2, bin TCC, main.c, it still works, right? So we just added that feature, and that didn't break the code base of the compiler itself. So the feature is backward compatible. Well, it's really like, maybe there are some cases when it's not particularly backward compatible, but I mean, I recompile the compiler with itself and it just like works. And it's so beautiful, right? So the reason why it's so beautiful is that I can take this piece of code, just copy paste it and put it in here, right, and just comment it out, and that should work. That still works. Then I can uncomment this thing, pull it here, compile it one more time, and it still works. It makes it very ergonomic, right? So this simple feature makes it extremely ergonomic because I can just move this piece of code around without substituting anything, and it works, and it's backward compatible with this existing C code. It's just backward compatible. This is so fucking cool. So the question is, why wasn't it still not implemented? Right, so the only downside I see about this feature is that the new code that uses this feature is not compilable with all the compilers. Right, so that's the only downside, but is it really a downside? You know what I mean? It's just like, what do you think? Not forward compatible. Yeah, another downside is the C++ compatibility. Yeah, maybe that's the reason why it was not really implemented. But to be fair, these days the compatibility between C and C++ become worse and worse and worse, and the communities, C and C++ communities, are really diverging from each other, and they don't really care about each other much, right? C++ gained such, well, I mean, I said at the beginning of the stream that C++ is not really popular, but was actually saying that with a sarcasm. C++ is actually quite popular, right? So whatever I said at the beginning of the stream is more of a sarcasm, right? C++ gained some popularity, so it doesn't really need compatibility with C anymore, you know what I mean? Right, so the only reason why it needed is because it wanted to piggyback from the existing code base of C, but now it doesn't really need to do that. So maybe we reached the point where C and C++ can go different ways and nobody will care about that, because they really are different languages. So RamDev, thank you so much for 3 months of tier 1 subscription. Thank you, thank you, thank you. Some people might argue that Arrow is more readable. Readability is really difficult to quantify. Readability is very subjective. So this code is not readable for somebody who doesn't do programming at all. Like, how do you quantify the readability? Like, you don't know C programming language. This is not readable for you. It's really subjective. So there's more like quantifiable thing, right? So how easy it is to move a piece of code around, right? This increases the amount of contexts in which this piece of code is correct, right? So this piece of code is correct in this context. This piece of code is correct in this context. So it's an easily quantifiable thing. So we had one context in which it is correct. Now we have two contexts in which it's correct. Really objective, really easily quantifiable thing. None of that readability, which is impossible to quantify whatsoever. This is easily quantifiable. Readability, maintainability, these are very abstract words that don't really mean anything, but are used to justify very horrible programming practices. Like, think about that. They don't really mean anything, but people used to justify like things that make other people miserable at workplace. So does it still require address of operator? What is the address of operator when you pass the variable to function? Address of operator, I'm not really sure what you mean by that. What do you do for a living? I don't live. What do you think about readability of TCC source code? I can read it. Oh yeah, you still need to reference this thing. That's for sure. I mean that makes sense. That makes sense. All right, so it's actually pretty cool. I wonder what else can we do. It would be nice to maybe write a simple game, maybe, just to see how all of that will work. But I don't know what kind of game to write. Does it work on unions? That's a good question, actually. Let me try to do this. It should work on unions because we're using the code that, you know, that just works. Okay, so as you can see, this thing works. And if I move this thing, right, still works. Still working. Tic-tac-toe. Tic-tac-toe, tic-tac-toe. I want to write a game where this feature kind of makes sense. Usually how I implement applications, I just pile the code until it starts repeating itself. And then I start factoring out the repeating patterns, right? And once I start factoring out repeating patterns, this is where I would probably need that feature. So I just need to come up with an application where this kind of thing would make sense. You know what I mean? And also, so the application has to be complex enough. So for that application to be complex enough, I think I need to maybe be able to link with something like SDL. Sudoku generator, it's too complicated actually, right? So I don't really want to spend too much time on this kind of stuff. So let's try to include, you know, SDL2, and see if I can compile this thing. Right, so, so it's trying to include the SSE intrinsics or something like that. Let's actually go there. Can I just say defined disable? Okay, let's disable that thing, right? Let's in fact disable that thing because I'm not sure if it will work. Okay, so that kind of worked. So let's do SDL init, SDL video, init video, I suppose. So this is SDL init video. So init this thing failed, right? So we have to say something like SDL, maybe printf, right? SDL error, s SDL get error. something like this. So we got a raid from DigitalOcean TV. Thank you so much, DigitalOcean, for raiding me. By the way, DigitalOcean recently terminated my account because I couldn't pay for VPSs. So I had like outstanding bill or something like that, and I couldn't pay for that because all of my paying methods are under sanctions. And I actually reached out to the support saying that, guys, I'm in Russia right now, so I can't really pay. Can you just, like, you know, freeze the account until I can actually do that? And they said, we can't really do anything, just try some stuff. And that's it. And then at some point I got automatically terminated, so I just don't have a DigitalOcean account anymore. So DigitalOcean, if you're a real DigitalOcean, thank you so much for the raid. I really appreciate it. Very cool. So anyway, I mean, I completely understand why it happens, so it's fine. I'm not complaining, just saying that it's kind of funny. No, I don't hate them. Like, I really don't hate them. They did what they're supposed to do, and given the situation, right? So, like, I have nobody to blame for that. I'm just saying that it's kind of funny. So, yeah, I can't blame them, so it's fair. Anyway. So what do we have? So let's actually try to do this entire thing. So we have a semicolon. Let's see. Undefined symbol. So this is what I want you to see. So it's LSDL2. And okay, so we have to also link with Pulse Audio. Pulse Audio. Pulse Audio. I think this is how I pronounce that. You have to put verbals in a shoebox with a sail and then put it in. Yeah, that's what I have to. All right. So how can I link Pulse Audio? So maybe I just have to do something like all Pulse. Maybe all Pulse simple? Is that what I have to do? Didn't really complain about anything here. Yet you were still buying oil in millions. Yeah, it's kind of fucked up. So I could try to use package config, right? So see like libs, and then I can put SDL2 in here. But in here we only link with just SDL2. It has nothing to do with Pulse Audio. And what's funny is that I'm not even using audio. Right, and I wonder if I can disable the audio. So that's a good question. So I just don't really want to go into the huge rabbit hole. Right, so init audio, and it's just like, yeah, it needs the audio anyway. Pulse, so sound. Audio. Okay, so SDL audio. So this is because it includes it. So which makes me think I can't not include the audio. It always includes the audio no matter what. So which makes me think, can I disable this kind of stuff? No, I can't really disable, so I have to link with Pulse Audio. Package config list all. Yeah. Pulse, so lib pulse. Lips, lip pulse, and it's just like L pulse, right? But do you also have simple? Simple, lip pulse simple, and lip pulse simple for lips. Lip pulse simple. Yeah, it's just this one. So, and I feel like I tried to do that. I'm pretty sure I tried to do that. Right, both of them. And it complained that it couldn't, but maybe this is because of the order in which I tried to do that. No, okay. So you also need some sort of a common. Okay. L pulse common. Okay. L pulse common is not found. So this is a rabbit hole that I don't really want to go into, so we'll probably not have to... We should not use SDL. Yeah, we definitely should not use SDL. Maybe DL, but how is it going to help me? I mean, not DL, but LDL, right? Just saying random things. Gia, thank you so much for 36 months of Tier 2 subscription. Thank you, thank you, thank you. 3 years. Sleeper AF, so just dropping by. Okay, bye. Bye. Thank you so much. Right. So, by the way, did you see what we implemented? Did you see what we implemented? We actually implemented a very cool shit, right? So you have something like this, right? So you have a code that just uses the structure, right? 34, and then B35, and then we can say printf d foo a foo b, right? So let's try to compile this entire thing, and then maybe even run it. Like so. There we go. It says 69. So now, what if I want to refactor this code and pass this code by a reference, like so? So I'm gonna just copy paste this code, right? And in the spirit of C and C++, you would have to replace this dot with arrows. But no, not anymore, because we implemented after dereferencing. So, and what's interesting here is that when we encounter dot, we look at the, like, you know, the left-hand side, right? And if it's a pointer, we automatically dereference it. We just automatically dereference that thing. So you no longer have to replace it with arrow. And you know what's cool? It doesn't break any of the existing code because you still can use arrows. You still can use them. Because of that, it doesn't break any existing code. It's backward compatible. Right, so this is the feature that I had in, like, at the back of my head for quite some time, and I was thinking why nobody implemented that, because it's like, it's backward compatible. Of course it breaks C++, but who cares about C++? I mean, you know what I mean? So what I did, I just took TCC and I just like implemented it, and I recompiled TCC again with that feature on, and it recompiled and it didn't break anything. Sort of kind of confirming to some degree that it's backward compatible. Right, so yeah, that's pretty cool. C++ 23 feature, yeah, probably. All right, so, and I was thinking like I wanted to try it for like, for a real application, right? Where I would develop something and then start refactoring things around, and but I need to come up with a like more or less substantial thing where this stuff will shine. I don't know. So I was trying to make SDL work with TCC, but for some reason it doesn't really link because it wants pulse audio. It doesn't really do anything. So maybe because of that we're gonna be using the how do you call it, the text interface, right? The text interface. How can we implement the text interface? So what we want to do, we want to do tic-tac-toe, right? So if we're gonna implement tic-tac-toe, we need to be able to, you know, have some sort of a field, right? So let's define rows. It's gonna be 3 by 3, but I'm gonna define this thing anyway, because I want this thing to be customizable, right? So, and we're going to have a board. So it's gonna have these rows and these columns, right? And the board itself should probably have 3. You know, the cell in the board should have like 3 things. So this is a cell. And a cell could be some sort of enumeration, right? So this is a cell, and we can have cell empty, which is initially 0, cell X, and cell O, right? So X and cell O. So maybe we can also define something like struct board, and here we have cells, right? So this is the board. And yeah, Rutifan, thank you so much for a tier 1 subscription. By the way, if I missed any subscriptions, I'm really, really sorry. Thank you for everyone. Okay. Okay, so if we define some sort of a board, right? So this is the board, and we're gonna also set it to 0. I'm gonna set it to static, so it does not allocate on the stack. And let's try to come up with a way to render this board, right? So this is gonna be something like row from 0, row less than rows, plus row, then for int column, 0 column calls, plus column, right? And in here we have to print something in here, right? So maybe we want to have a table, right? Some sort of a table where we have something like count cells, right? So that gives us the amount of cells we have, the amount of kinds of cells. So, and here we have cells chars, count cells. So, and in here, we want to say that for cell empty, we're going to have a dot, so we can clearly see that we have that. Then X is going to be X, and O is going to be O. I'm not really sure if TCC supports this syntax. It probably does not. So, yeah. Anyway, then what I want to do in here, I want to do something like C, and then I'm gonna do cells chars, board cells row column, right? So essentially the value of the cell I use as an index within the table to look up these things, which is rather dangerous thing to do because, you know, there's no out of bounds checks because this is C, right? But I'm gonna do that anyway. So maybe it would also make sense to actually just put C, right? Because we're putting a single character in here, so it doesn't really make much sense to do anything else. Std out, there we go. So let's see if we manage to print this entire thing. So it didn't really recompile anything. I'm actually surprised. Why does it still print 69? Oh, I see. This is because I'm an idiot. Alright, so now we have this thing. This is a 3 by 3. Right, this is a 3 by 3. And now I can probably change some of these things. I can say it's a 10 by 10. Right. So, and again, it is super easy to now factor out this code by saying something like board render, right? And say, okay, let's accept by a pointer, right? And then I just copy paste this entire code, right? I copy paste this entire code and say board render, board, and it still works. So that's pretty cool. So it makes it super easy to factor things out. So whether it's a pointer or not pointer, it doesn't really matter. Cool. So, but this is going to be 3 by 3. I need to have some sort of an interface, right, where I could pick a character, right? You know what I mean? Like a pick a character somehow. So, which means that maybe I'm gonna do it the following way. So I'm gonna put spaces around each individual cell, right? So this is gonna be space, and this is gonna be another space. So identify expected. So what the hell is going on? So I thought it worked. And now identify expected. It's probably because of... But how did it work? Wait. What the hell? How did it work then? Cell. Is this because of that? I have a strange feeling that maybe this is because of that. Okay, so let me put it this way. Is that because of that? No. Am I going crazy? Okay, I am going crazy. Which actually kind of cool that this syntax actually works in here. Alright. So what I want you to do, I want you to put spaces around the cell. Right, I want you to put spaces around the cell. And for instance, if row equal 1 and column equal 1, maybe I'm gonna put it this way. If that's, I'm gonna do that. And then here, I'm gonna do something like this. There we go. So essentially, I want to have some sort of a cursor, right? And then with arrows, I could just basically select a certain cell, if you know what I mean. So we want to have a cursor. We want to have some sort of cursor. But the question is, how are we going to be controlling that cursor? How are we going to be controlling that cursor? We can start within the board, but in that case, this is not a board anymore. This is more of a game state. All right, so we could probably rename it to game. So this is a game, game render, board game. So this is a game. Alrighty. We need to organize some sort of a loop, right? We need to organize some sort of a loop. Where not quit. And maybe quit is supposed to be part of the game, right? So let's put quit in here. So boolean is not available. I wonder if I can do std boolean. Okay, I can. That's pretty cool. So yeah, I still use dot in here. I still use dot in here. There's no difference in here. So it's like in Rust, right? So it's just like in Rust. It doesn't matter. It's auto-dereferenced. And another thing is that I need to define directions, right? I need to define directions. So it's going to be type def enumeration, direction left, right, up, and down, right? So that way I can have something like game move, where I have a game and then just a direction. So, and then interesting enough, I could probably do something like if direction is direction left, I just do game, right, because I also have to store the cursor, right? So we're gonna have something like cursor, maybe cur row, cur column, right? So something like that. And I wonder if I can do, if it's left, I have to do column minus 1. but I also have to keep it within the range, if you know what I mean. So I wonder if I can do some stuff like, though maybe I could just do a mod afterwards, right? So write plus, then up, it's a row, so it's actually minus, and down plus, right? So align. Can I align the game? I think I can, right? So after that, I could probably wanna do something like mod count dir. Actually, what am I talking about? Calls. But here I have to use emod, right? So I have to use emod, so it probably wraps around. But does it have to wrap around? I didn't think so. I actually don't think so. So it has to be something like, if it's less than 0, it has to be equal to 0. If it's greater or equal to columns minus 1. And the same goes for rows. Right, so maybe I can replace call with row and go. Something like this. That's it's a weird code, but I mean, sure, why not? So here we also have to wait for a certain command, right, to be entered. And what I'm thinking is that maybe we can use something like fgets, right? Fgets. So we're going to be reading that command into some sort of a buffer. So, but we need to have such buffer defined somewhere, right? So let's define cmd buffer, and inside of that buffer is going to be, let's say, 256. So it doesn't really matter. So this is a cmd. Then the size is going to be size of that buffer specifically, and we're reading from stdout. The cool thing about fgets is that it reads until the end of the line. Right. So after that, what we can do? We can essentially iterate through all of these commands somehow. What I'm thinking is that we need a size, right? So let's define n strlen cmd, right? And then we can do size t n plus I, and here we can switch between different things, right? So we can switch cmdi, right? Case. So what kind of cases can we have? So it's gonna be w, right? Because of that, like, I mean, we can directly just do these kind of things, if you know what I mean. Seriously, like, do we really need to introduce the directions? Let's actually keep the code simple. So I'm just thinking that I might be a little bit overcomplicating stuff, right? So here we can have a case, and depending on the stuff, we can have different cases. So let's align game. So this is left A, then D, W, S. In case of the default, we don't really do anything. And in case of like break, we just do that. And then here somewhere we can limit the, you know, this thing. Which kind of means that I don't really need this function. Okay, so will you get the money if we donate bitcoins? No, I won't get the money. Don't worry about it. So, all right. Okay, incompatible assignment from incompatible pointer. Implicit declaration of strlen. So let's include string. Assignment from incompatible type. What are you talking about? Assignment from incompatible type. I'm not doing any assignment in here. Probably because... Okay, so this could be because of this thing. Field not found column. Oh, this is because it's a cursor column. Cursor column. Did I call it cursor column? I call it cur. Okay. Cur column. There we go. Okay, so another thing in here. This is annoying. This is not what I wanted. Okay, it doesn't matter. Cool. So let's see if it works or not. Right, let's see if it works. So, while not quit, which is also rather interesting. Can we do just something like this? Right, so this is going to be break, and then I can say quit. We can say quit. Okay, cool. That is very, very cool. And what's funny is that it doesn't wait for the input. This is because I'm using stdout instead of stdint. Right, and now I should be able to do these kind of things, and they don't really work, which is also rather interesting. So do we... Oh yeah, I see. This is because we have to use this stuff in here. Right. So you know how we're gonna do that? Selected. Right, selected is essentially row is equal to game cursor row, and column equal to game cursor column. Right. So also here we can say selected. There we go. And now I can do stuff like that. So as you can see. So it would be also kind of cool to, before we ask for the command, right, before we ask for the command, to print the prompt, so-called prompt. Yep. Yeah. So as you can see, we can do these kind of things. Alright, so we can select stuff. The question is, how can we put something in there? Right, so we need to put something in there. And yet again, this gives us a pretty cool opportunity to maybe still factor out things, right? Still factor out things. Let's do something like game move, where I accept the pointer to the game and the character, the command that we use in here. So interestingly, yeah, I can just take this switch, actually not only this switch, but this entire thing, just copy paste it in here. I'm just copy pasting it in here, replacing that with that, and then I just do game move, pointer to the game, and then cmdi, and I don't have to change anything, it still compiles, yet again. Right, so this is the reason why I implemented that feature, is that now I can just copy paste pieces of code and that will still work. Right, so that's pretty cool. That is actually really cool. Okay, so and one of the things we want to do in here is now essentially make a move. So let's say that we're gonna make a move on space, right? So this is gonna be space, and when you know, set the space, we need to put something in there, right? We need to put something in there. So game cells game cursor cursor row game cursor column is going to be set to, I suppose, the current player, right? So we can have a player, right? So this is the player, and the player is going to be the cell of some sort. It's really uncertain, which is rather interesting, right? So how can I represent the player? So the easiest thing would be to say something like, okay, this is the current player, but it's actually not. So there's no easy way for me to represent the empty cell then. So maybe we need to somehow separate the cell and the player. You know what I mean? We could have something like enumeration player, maybe even shape, right? Shape X and shape O, right? X is going to be 0, O is going to be 1. So, and cell is going to be empty and maybe full, right? Empty or full. So, and what's interesting is that full is essentially, right, if you want to put X in there, you would do cell full plus shape X. And if you want to put O in here, you will do plus O. So this thing sort of defines an offset for this thing. Does it make sense? I'm not sure if it makes sense, but yeah. So the reason why I want to do something like that is because now I want to define shape as a player, and default value for the player is going to be 0, which is X, right? And then flip-flopping between the players is as easy as player minus player, like that. So that allows you to flip-flop between them, or maybe even do something like that, but I don't think so. Just look 1 minus that. So that's why I want to do it this way, right? And at the same time, for the cells, I still want the default value 0 to be like empty cell, right? So essentially my philosophy is that, I really hate this word, but my principle is that when I define a structure, right, I want if you 0 initialize the entire structure, it's still a valid structure and it has a default value, right? So for quit, the default value 0, false, makes sense. So if you 0 initialize all the cells, that means the 0 has to be an empty cell, right? And this thing with 0 initialized means that it's X, right? That's why this code, this approach, kind of wants a separation between cell and a shape. You know what I mean? So maybe I should not separate these two notions, but the approach that I'm using kind of wants to separate them. Does it make sense? Hopefully that makes sense. Anyway. So, but that breaks this thing, right? So that kind of breaks this thing. So maybe we want to do something like that. So shape, characters, we want to have count shapes. Maybe I'm overcomplicating things, who knows? I like to overcomplicate things. And in here we have more of like a shape. Okay. So directions, we don't really have directions. This doesn't really matter. So if it's a player, I'm gonna put it like that. Okay, let's try to compile this entire thing and go through the compilation errors. Count shapes, should be called shapes. Shape characters. So this one, shape, cell. Oh, this is actually very cool. So look at it. I can do the following thing. So might as well even take a cell, just a pointer to this entire thing. And if cell is empty, right? If cell is empty, I do cell full plus shape. This is very cool. So it even like makes sense, right? That is very cool. so cell is empty, and you want to make it full, and you add the shape, and that's what it is. Very cool. Alright, cell is undeclared. Oh yeah. Is that because we don't have a cell? What are you talking about? Oh, I think I know what it is. This is because I need to do something like this. Okay, so that seems to be working, but I think rendering is broken. I feel like rendering is broken because, yeah, this is not how it works. Okay, so what I need to do is probably... if cell is empty, right, if it is empty, I just put dot in here, std out. Otherwise, do shape characters. Cell, this, cell, full. Might as well. If it's empty, dot. Is that a good idea? Maybe. I'm not really sure. It still compiles though. Cool. So now if I do game move, right, so this is a space, I just check for whether it's empty or not. Only if it's empty, and only then I switch to a different shape, and I switch it like this. Game shape. Okay, so then I go here. Okay. Okay, so I can actually set things in there. That's pretty cool. So as you can see, I can just like flip-flop and stuff like that. So the only thing we need to do is to check for the win condition, right? But apart from that, like already, this is actually pretty comfortable. I really like how I don't have to think whether I have to put like a arrow or dot. I just always put dot and it works. And I really, really like that. So let's check for the condition. So how we're gonna have a win condition? Win condition. Game. So we can have like a crosses or knots. So there's like 4 outcomes, right? So if we have something like check victory, right? So you can check a victory, and you have an outcome, right? So here's the outcome, and we kind of have like a 4 outcomes, if you know what I mean. So the first one is none. So you continue playing, right? Then you have a tie, right? So this is a tie. And then you have something like X and O. So how can we encode these 4 things? Do we use enumeration or do we use something else? Will it dereference multiple levels of pointers? Probably not. Because it only does one dereferencing. So essentially, the way we implemented that is that when we encounter dot, we check whether the left side is a pointer. And if it's a pointer, we kind of replace the dot with an arrow. And the way it works is we just call the code that is called when you have an error in here. So it's literally, this makes these 2 statements equivalent on the level of the compiler, right? So the question is, can it dereference multiple levels? Well, can this code dereference multiple levels? The answer is no. So neither can this code, right? So yeah, at compile time we just like take a look at the dot and we replace it with an arrow. So so what I'm thinking is that we can do the following thing. The outcome could be a mask. You know what I mean? where only 2 bits matter, right? So 0 means nobody won, right? So we continue playing. 0, 1 means not won. 1, 0 means no, it's crosses 1. This one means not, and 1, 1 means tie. We have exactly 4 of these things, and because of that we can just like maybe return an integer of some sort, right? Doesn't really matter. So, and the way I'm gonna encode all of that is essentially it's a midnight. I don't know what the fuck people do. Imagine living among the orcs. So everyone, what's up? What's up? Okay, so, and the way it works essentially, right? So returning 0 means we continue playing. Returning 1, shape X, right? Shape X means we return that thing, because X is equal to 0, so by doing that you just have like 1, right? Then you have O, and you get this thing. So, and then if you want to say that it's a tie, it's gonna be effectively this or this, right? You see what I mean? So that kind of forms like a consistent system, if you know what I mean, right? Because X is 0, O is 1, continue playing, that one, this one, both of them 1, right? It's a tie. So, and that way we don't really need another enumeration with 4 values. We just use a mask to encode the outcome. So I guess that makes sense. All right. So how can we check all of that? Ooh. Yes. The game should be called Xoxo. Right. So essentially we can check different rows, right? So then we can check the diagonals and some other things. Though maybe checking for tie doesn't really make much sense, does it? Because tie is basically when everything is filled. But there's no condition, victory condition. Okay. Check a row, right? So we check in the row, we provide the specific row, and then we provide also specific shape. So that means here for column equals 0, right? So column equals 0, column less than cols plus col. If I can put it this way, if we have to actually accept the game. So here's the game. We can also accept it like this. The game. Game cells row column. Game cells row and column. If they're not equal to s, right? If they're not equal to s, we just automatically return false. Right, otherwise we return true. That means both of the, like, the entire row contains this entire thing. So now we need to check the column, right? So this is the column, this is the column, this is the rows. So it's the entire thing. So then we need to check the diagonal, right? So check, it's more of like a main diagonal. Const game shape s. So this is the main diagonal. For you know what? This is kind of weird. What if this is not a square? So this is dangerous. Okay, so this is a size. It's going to be 3, and this is the size, right? So I'll get back to that a little bit later. If game sells I not equal s, return false. Okay, so we have a main diagonal. Cool. So then we want to have like a secondary diagonal, I suppose. Right, so sec. And here, so this is going to be that, and here is size minus I, I suppose. Yeah, -1. Yeah, that's the secondary diagonal. So, and now we can check for different shapes. We can check for different shapes. How can we check for different shapes? So we can do something like shape 0, shape less than count shapes, right? Plus shape. So this is the shapes that we're checking for. Might as well actually call them S, right? So this is S. And here we do something like I, size plus I. And essentially, if check a row, game I, S, right? So game I, S. Check return. I return S. If check column game I S, return S. Which also means that maybe I can just, do something like this, but it's not particularly readable for me, at least. Main diagonal. And this is the secondary diagonal. There we go. So interestingly, since it's a shape, I have to do something like this, right? So yeah. So you see how it works? You see how it works? So first we look into the first shape. We check all of the rows, columns, main diagonal, secondary diagonals. And then we go to the second shape, and that's how we return this, I think. The diagonals can be outside the loop. Yeah, that's actually true. That is actually true. Okay, so in here we can return 0. So I'm not sure about tie, because it feels like tie is just like when we filled everything, but still nobody won, right? So maybe because of that, we just need to keep track of how many cells we're already filled. Right. So field count. Something like that. Alright, so we do that, then game field count +1. And this is where we can check this entire thing, right? So outcome game check victory, right? If outcome contains something, right? If outcome contains something, what we want to do? We want to do something like C outcome. Actually, what the hell am I doing? I need to... Oh, interestingly... Brain doesn't work anymore. But anyway, if there's no outcome, but... field count is equal to rows multiplied by calls. Right? We have to do printf tie and just quit the entire game. Yeah. So in this particular case, what we have to do, we have to check which shape won. So since we return this thing as the mask, it's kind of difficult to do that. But again, the only reason why I decided to use a mask is because I wanted to account for tie. But we don't really need the tie. You know what I mean? We don't really need the tie, so that means I can do something like s plus 1. Right. Def int outcome. So that means I can just take outcome -1, shape characters like this, and then say 1. There we go. So that's what we can do. Can we compile this entire thing? And let's go. Okay. I think I'm an idiot. Cool. You know why? Because I got confused myself. Right. So essentially what I... yeah. This actually makes it complicated. It's not equal empty. Yeah. And then I have to do cell full. Though, if it's an integer, I can just subtract full, and maybe that will work. That was a really bad idea with all of this stuff. So I think I overcomplicating things yet again, but it's fine. Check row, check diagonals, and then just like do that. So full. Alright. So yeah, x1. When we win, I suppose we also want to print the last state. Because of that, it probably makes sense to actually render after handling the command, right? And then just like render for the first time. And let's just do that. Okay, so well, I mean, it said 1, but then okay, I see. Maybe it makes sense to do something like that, right? And then just put it this way, so always print. You see what I mean? Right. You see what I mean? Summit for incompatible type. Oh, okay, that's cool. All right, thank you. Yep. Yeah, there we go. So that's what I want. You know what's cool about this entire thing? You won't be able to compile this game with GCC. GCC can't compile this game because it wants arrows in all of these places. Right. It wants arrows in all of these cases, but our version of the compiler doesn't require all of them, and that works. How about that? Isn't that cool? Right, so I can give you the source code of this game, but you won't be able to compile it without modifying either the source code of the game or the source code of the compiler. That's the cool thing about this thing. It won't compile unless you have the correct compiler or you change the code. So it's so cool. You guys want this piece of code? Like, I mean, I can give you, sure. Though I have a better idea. So I think I also need to give you the patch to TCC. So I'm gonna do something like patched, right? And I'm gonna try to uncomment this thing one more time. And I wonder, I think I only made the changes in the TCC gen. So what I need to do here is TCC gen, TCC patch, TCC gen, TCC patch. Right, so this is the patch. That's the patch that you have to apply to this thing. I'm not sure about the cert, right? I'm not sure about the cert, but yeah. Okay. So, and I want to compose all of that into like a single repo that you can like download and stuff like that. Does the patch contain like the versions? Yeah, it does contain the versions, so you know how to apply this entire stuff. Tic-tac-toe auto-deref. Auto-deref. So, and I'm gonna... so this is not a particularly great name. The original C only had dot and dereference pointers, then they decided to add arrow before it was standardized. God damn. That was actually pretty close. Interesting. So why they decided to do that? To be more explicit? Because, you know, explicit is better than implicit. Am I right? So they were following the Python Zen or whatever it's called, I don't know. That's probably why, but Python didn't exist back then. So this is a very long name, so how should I rename it? Tic-tac-toe out deref. Yeah. Anyway, so let me move this thing. So I'm gonna copy paste this stuff in here and this stuff in here. So the license, I'm gonna release everything under MIT. You can do whatever you want. Readme. Tic-tac-toe in C, but without dereferencing. So a simple experiment to that adds auto dereferencing of the structures to C programming language. So, and speaking of auto dereferencing, right, you can read more about auto dereferencing in this tweet. Right, so if you want to know what I'm talking about, this is basically the tweet where I introduced the auto dereferencing for C. So a simple experiment that adds auto dereferencing C. This is a simple tic-tac-toe game that won't compile on your machine unless you change its code or compile with TCC to which you that is patched with TCC patch. There we go. So let me find TCC. So here's TCC. Maybe I should actually refer to the sort of like official website or something. That is patched with TCC patch, right? So quick start. So let me try to document the quick start. I think it's something along the lines wget. So let me actually replicate that. Right, so I'm gonna go ahead. Oh yeah, I have everything. I have everything that is needed. So wget, then tar fvx, and then cd there. All right, so let's start. Oh shit, I should have actually put it like ampersand there so it will show the progress, but I mean, it's pretty fast. That one, I think only this one. Okay, so then there I have to do configure. Yeah, I think I just have to do configure. Right. Then make. Do I have to do install? Make install. Oh, I forgot that I have to apply the patch. How do I apply the patch? So I think I have to do apply. Do I apply it with this thing? Apply. Patch tries to apply. Linux apply patch. I don't remember how to use that, I'm sorry. How to apply a patch file to my Linux Unix source code. Patch. Oh, I see. So this is kind of a patch will patch the diff file. Okay, so that's very interesting. So patch. But do I have to specify the... Probably not. I'll create a patch. Okay, so that makes sense. So patch tcc. Oh, since we moved there, we're already inside of it. So I have to patch tcc gen and then something like tcc patch. Right. So then if I go to tcc gen c struct or union. Okay, so it applied the patch. Okay, that's cool. So that instruction kind of worked. So that means I can just take this thing and put it in here. So this is how you would apply that. Right, so you do sd, then you apply this patch, configure, make install, then do tcc. Right. I guess, I don't even know. Then I probably have to go back. Right, something like this then. tcc main.c main. Okay, so that's roughly how we would do that. That's roughly how we would do that, and I think we're ready to git init this entire thing. All right. So ready, set, go. And let me create the repo. Oh man, probably. Sure. Thank you for suggestion. So tic-tac-toe. A simple command that adds out the referencing. So I probably need to remove the link. Okay, so we have that. Then this is going to be public, and then I'm going to create a repo. Then I'm gonna add origin and tic-tac-toe. This is gonna be the main thing, and I'm gonna push that right into the repo, mate. Right into the repo. Cool. So now this thing is available for everyone. So what do you guys think? What do you guys think about this little experiment? So this is a piece of code that is not compilable in any existing C compiler. It is not compilable by any existing C compiler unless you apply the patch to the TCC. Right. So, and to be fair, it is actually very convenient that you don't have to think like reference, dereference, and I mean, you still don't have to think because the compiler will tell you, but it's kind of like removes one of these like little frictions of the language, and again, doesn't really, you know, break any of the existing code, right? Doesn't really break any of the existing code. So I think that was actually a pretty cool experiment. What do you think? Definitely improves the ergonomics. Yeah, I also think so. Okay. I guess that's it for today. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you next time. And yeah, love you. Stay safe. Mwah.